Your MCP server works perfectly in development, but browser-based clients like MCP Inspector fail with cryptic CORS errors when you try to connect. We'll configure the exact CORS middleware settings needed for FastMCP's protocol headers, showing how to expose the required session ID while keeping your server secure. You'll see the precise middleware setup that makes browser-based MCP tools work reliably. From FastMCP, import FastMCP. From Starlette, middleware import middleware. From Starlette, middleware, CORS import CORSMiddleware. MCP equals FastMCP, my server. Hash configure CORS for browser-based clients. Middleware equals middleware, CORSMiddleware. Allow origins equals asterisk, hash allow all origins. Use specific origins for security. Allow methods equals get, post, delete, options. Allow headers equals mcp-protocol-version, mcp-session-id, authorization, content type. Expose headers equals mcp-session-id. App equals MCP. HTTP app, middleware equals middleware. This demonstrates the middleware pipeline pattern for ASGI applications, specifically showing how to inject cross-cutting concerns like CORS into a FastMCP server. The pattern wraps your core application logic with reusable processing layers that handle orthogonal requirements, security, protocol compliance, or request transformation, without modifying the business logic itself. What makes this distinctive is the clean separation between your MCP tools and infrastructure concerns like browser compatibility. The pattern works by composing middleware components around your application core, where each layer processes requests and responses in sequence. FastMCP HTTP app method generates a standard ASGI application that can accept middleware stacks, allowing you to add CORS support, authentication, or logging as modular components. This follows the chain of responsibility principle, where each middleware either handles the request or delegates to the next layer, keeping your tool implementations unaware of transport-level details. This approach matters because it solves the problem of protocol-specific requirements leaking into your business logic. For browser-based MCP clients, CORS headers are mandatory but irrelevant to your tool implementations. By externalizing these concerns into middleware, you maintain clean tool definitions while supporting diverse client environments. The trade-off is slight runtime overhead from the middleware chain, but the flexibility to adapt to different deployment contexts, whether browser, CLI, or cloud, justifies the pattern. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for building AI-callable tool servers. It handles the protocol translation between Python functions and AI model requests, eliminating manual schema definitions. From Starlette, middleware import middleware. Imports middleware from Starlette, the foundational class for HTTP request-response interception. This enables CORS configuration and other cross-cutting concerns like authentication or logging. From Starlette, middleware, CORS import CORSMiddleware. This imports CORSMiddleware from Starlette, the middleware that handles cross-origin resource sharing. Without it, browsers block requests from different origins, breaking web-based clients. MCP equals FastMCP, my server. This initializes the FastMCP server instance named my server. This is the entry point for creating AI-callable tools and HTTP endpoints, serving as the core controller for your MCP application. Hash configure CORS for browser-based clients. Middleware equals. This initializes the middleware list for CORS configuration. Middleware processes requests before they reach your root handlers, enabling cross-origin requests from browser-based clients while maintaining security control.
Middleware.
Middleware is Starlette's composition pattern for wrapping HTTP requests with reusable processing layers. This instantiates the CORSMiddleware component, which will intercept and modify requests before they reach your root handlers. The pattern enables clean separation of cross-cutting concerns like security, logging, or request transformation.
CORSMiddleware.
CORSMiddleware is Starlette's built-in CORS handler that enforces cross-origin security policies. It intercepts HTTP requests to validate origin, methods, and headers before they reach your FastMCP endpoints, preventing unauthorized cross-site access. This is the standard middleware pattern for adding request preprocessing to ASGI applications.
Allow origins equals *, hash allow all origins. Use specific origins for security.
This enables CORS for all domains using the wildcard origin. Critical for browser-based clients, but insecure for production. Replace with explicit allowed origins before deployment.
Allow methods equals get, post, delete, options.
This restricts HTTP methods to get, post, delete, and options. It explicitly blocks unsafe methods like PUT or patch, reducing attack surface while maintaining standard REST functionality. The options method is required for CORS preflight requests.
Allow headers equals.
This defines which HTTP headers the browser can include in cross-origin requests. Without this, CORS would block requests containing these headers, breaking authentication and session management. The list includes MCP-specific headers for protocol versioning and session tracking, plus standard auth and content type headers.
mcp-protocol-version.
This header specifies the mcp-protocol-version in requests, enabling version negotiation between client and server. Critical for backward compatibility when the protocol evolves, it ensures clients and servers agree on message formats and capabilities before communication begins.
mcp-session-id.
This exposes the mcp-session-id header to browser clients, enabling session persistence across requests. Without this, the browser couldn't read the session ID from responses, breaking stateful interactions like authentication flows. Standard CORS practice for session-based APIs.
Authorization.
This enables the authorization header, allowing clients to send authentication credentials like API keys or JWT tokens. Critical for securing endpoints, it ensures only authorized requests can access protected resources. Without this, authentication headers would be blocked by CORS, breaking security flows.
Content type.
Content type header enables proper request response body parsing. Without it, the server can't determine if the payload is JSON, form data, or raw text, leading to failed API calls. This is mandatory for any HTTP API handling structured data. This closing square bracket terminates the Allow Headers list in the CORSMiddleware configuration. It finalizes which HTTP headers the server will accept from incoming requests, completing the security policy definition before moving to the next middleware parameter.
Expose headers equals mcp-session-id.
This exposes the mcp-session-id header to browser clients, enabling session tracking across requests. Without this, browsers couldn't read the session ID from responses, breaking stateful interactions. Standard CORS security practice. Explicitly whitelist only required headers. This closing parenthesis terminates the CORS middleware configuration. It finalizes the middleware stack definition, which will be applied to all incoming HTTP requests to enforce CORS policies and header handling. This closing square bracket terminates the middleware list configuration. It finalizes the CORS settings we defined, ensuring they're properly passed to the FastMCP HTTP application during initialization.
App equals MCP. HTTP app. Middleware equals middleware.
This instantiates the FastMCP HTTP application with the configured middleware stack. The middleware list we defined earlier, including CORS handling, is injected here, ensuring every request passes through those layers before reaching your tools. This is the standard pattern for composing Starlette/ASGI applications with reusable middleware components. CORS configuration pattern. This middleware setup bridges browser-based MCP clients with your server, exposing specific MCP protocol headers while maintaining security boundaries. The wildcard origin is convenient for development, but should never be used in production without additional security layers. Always validate the exact headers your MCP clients require, as missing protocol headers will silently break browser-based connections.
The middleware that stands between everything connects nothing.